So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This is video 293, and in this video we continue with our expressions, and we have here talked about operators, operands, and here about this conversion, other primary expressions, and now literals as well. And now we are here on the section full expressions. And again, this is very theoretical, so don't worry if you don't understand all very well, because then you have to use a good C++ book or research online. But we are more concentrated on practical use, which means just try to see this a little bit and try to identify this in your code. So when you are able to identify this in your code a little bit, that's good to go. And the first rule is all time find an operator, operands, and a computation, then you are good to go, because that will be an expression, and then we can go on from this point. So we are here in the section full expressions, and when you read here a little bit the full expressions, I'm not going to read this all through now, because again it's very theoretical, and our job is just to understand perhaps this little example here is what is a full expression. And the definition here is down. You can pause the video, read this. I'm going down here to the examples, and you can see here we have here different cases, how this is defined and how this is used. And yeah, it is more like this constituent expression here. So here in this case, that it's the whole thing. And here is interesting that this array has parts when you are using it this way. Interesting, this part here, when you watch this one, this is here the case 2, where this becomes one part, this becomes one part as an expression, and when you go here to case 3, this becomes whole the part of an expression. They are showing it here how this is divided. Yes, and the reason why we have to understand this is probably there can be cases where you have to distinguish expressions, especially when you are converting or doing something. I don't know what we need with expressions later. We will see this. And then we can go on here a little bit, the immediate sub-expressions again. Sub-expressions now. Yeah, because they are talking not about one expression, they are talking now about how they are combined and then how they are treated, why they are used. Again, it's very theoretical, so you have to read this a little bit. I skip this because it is just reading, trying to understand. And if you are not understanding in this page, again, use a good C++ book, because this is theoretical part where they make a little bit more examples and trying to, yeah, show also more examples what they mean with that. And then they are going here in the last part to the full expression. So you can see they start this part here, then they go to the immediate sub-expression, and now they are going to full sub-expression. And to distinguish them, yes, you have to understand a little bit this part, then this part, and then you can go here and go to this full expression part here. Again, it's again theory, you have to read this one and go through it a little bit. And this kind of stuff I'm not doing here together, because it's theory, would take too much long, and it's just reading more or less. All right, but what we are going to do is we are just going on and see what we need for our code. Like I said, our job is to distinguish the parts, that you can all time categorize them, that you identify expressions. Like I said, when we have here something like this array, that is a little bit complicated, that you can see, okay, what part of this array here, or this whole thing here, what we have here is an expression or sub-expression, like they call it, or constituent expression, and all this kind of stuff. You see, it's not so super easy when we come to parts like this and then distinguishing that. But okay, I think in the end, in practical use case, it will be not that important. That's the good point. This is more like a little bit more theory. And we continue here a little bit and go here to potentially evaluated expressions. So here what we have to think again, it's much theory. Again, you try to find the operator. You can see the size of is again a word operator, which we have here on top of this list here. This is all time the first thing, and then you have to consider how this operator is behaving in the context and so on. That's and then you can see what they mean potentially evaluated. And potentially evaluated means it can be that there are problems, that it is not evaluated or something like that, or they have to wait something to wait that other things are evaluated first, and then they can perform their computation, because we learned expressions are in the end just a specific here specifies a computation, and this computation is only possible if the operator and the operands allow it. And that's why we have this section here, potentially, probably possible or not possible, and you can then read here the conditions when it's possible, when it's not possible, and which conditions are there. Like here we have here constraints. We have not talked about everything here because requires it's with templates, for example. We have not talked about that, so don't worry if you don't understand everything here, but in very general, without to go into deep, they say only every expression can't be evaluated, depends, like I said before, on the operands and constraints and so on. But that's again more theory part. We go a little bit over this one. Again, if you want to go here a little bit deeper, you have to read this. In the end, what you are doing is really you are going through these operators here, not only this one, of course, the other ones too, and then you are trying to understand them in context, how they are used in context, and that's what they are trying to explain you here in all this theory part. And and then we have here the one more thing. This is this discarded value expression, and the question is now why we would use this one. And when you read this first part here, they are only interested in the side effects. So this is that's why they call it here discarded value expressions. And again, what was side effects? Again, side effects are when you read this one, they are not interested in the expression. And again, what was expression? Expression is, yes, they are not interested in the computation of the operators and the operands. So they don't care about this one. They use the expression in this part here. They use the expression, and this expression itself had side effects, and side effects means it is not only doing this computation, what is normally doing an expression, because when you call an expression, you are interested in the computation. For example, if I call a plus b here, I'm interested in this result, the whole thing, right? But when they are calling it here, they are probably not interested in a plus b, because a plus b might do also other things. So, and these other things are here called the side effects, and they are just calling a plus b, for example, just because it is doing additional things which are not listed, which is not the primary goal. And you can read this one here, how they are explaining this one, and you can see again here how there are many examples here and so on. Again, it's theory, that's why I'm not diving too much into it. This will take a lot of time. We are trying again just to understand expressions. We go, what you have to do is try to, like all time, find an expression. What is here an expression? Yes, we have to find what? An operator. And then when we have an operator, and then comes the second step, what is that? to distinguish this operator if this becomes an expression. So with other words, if this one is a computation, in this case we learned it's a special case. Even it has an assignment operator, this one is a statement, declaration statement. But we learned also in our last video that can be confusing sometimes with this constant expression. This one is also more or less a declaration statement, because it is a statement we see here. It is declaring a new name, yes, but the whole thing is called constant expression. Again, yes, this kind of words we have to learn a little bit to distinguish, but again, don't worry, this is not so practical, it's more theoretical. But in practical, what you have to know is how you can use that. So the practical person is more interested how I'm using that, what is that, and how I'm using that, right? That's the most part. And that's very important for us, because here we have a declaration statement. We can name it now. But what is that? And then we will talk about this construct here later, not now, a little bit more in detail. But first of all, what is that? And then what is doing that? Is this now an expression? And then we have checked this one, checking this. Is this an expression? And then we have here an assignment, and then so on. So that will be interesting. Like I said, it's not easy, but the good thing is, for practical use, you have just tried to identify the code. So you have not really know every little name and distinguish in every context, because like I showed you here, the context can change, right? We have here, we call this one declaration statement, but here we call this almost the same thing. It's also a declaration statement, more or less, but here it has the word const. Now it is a constant expression, something like that. Yeah. So you see, theory is a little bit more theory. Practical is just a little bit more interested in the use case, in the practical use case in code, and we have to identify that. So this was this one, discarded value. We talked about it. They are only interested in the side effects. They are using the whole expression just because of the side effect. And you have to go through this one and watch this on your own. Again, it's a big topic here with different examples. But here, careful again. They are using L values, R values, and this one is the point where we want to go later. And I think then here's again expression equivalence. You can read this one as well. It's again something very theory. They call it equivalent when these conditions are true. If not, then not. And don't forget this little green indicators here. This is also very important, because if you have code from older or newer, they can different a little bit in behavior. Don't forget this as well. I think that's our little expression part. In the end, you have just to find operators, operands, and then the computation of this both parts. So you can see in the end, really, if you understand this little sentence and try to find to identify this in your code, you will find an expression. And we are going, of course, a little bit further, which means when I go here, for example, back to our language section, here are our categorize. We talk now about, first of all, we started talking about this big names here to categorize our code. Then we talked about statements. We figured out many things are statements, then different kind of statements, which is also organizing our code. Now we went in this video and in the last video so about more expressions, and now I want to go also in the next video about this category, value category. And you can see we have to know what an expression is, and this one we will talk about in the next video. See you there. And like all time, if you have any questions, anything what you want to ask in the comment section, see you there. Bye, good luck, and like all time, have fun and never give up.